Today we're going to be starting geometry and we're going to be looking at angles and congruence. So we have some ideas about angles. So a ray is a pair of lines consisting of a point on the line called the endpoint, the ray together with all the collinear points on the same line and the endpoint. So we have A, B, C. So this could be ray AB or ray AC. Then we have two collinear rays with a common endpoint are opposite rays. So we have opposite rays here, which make a straight angle. A straight angle has a measure of 180 degrees, making a straight line. So an angle is a pair of rays that have a common endpoint. So here we have ray AD, and we also have our ray from the beginning, AB or AC. So in this case, we have the angle DAB or DAC or just A, or we can go the other way around. The rays are called the sides of the angle, and the common endpoint is the vertex of the angle. So the rays make the side, the common endpoint makes the vertex, and then between the two rays, that's the measure angle. So points D, A, B, and C lie on the angle. So you notice they're all on the rays, so that's why they're on the angle. Then we have interior, that means inside of the angle. So those 3 points, G, F, and H, are between the two rays. Exterior lie outside, so here is our angle right here from the previous one. So these ones are all outside. And then congruent angles are angles that are equal to each other. So we have angle QTR and angle RTS. So this angle is the same as this angle. I mean, they're congruent, so they means they have the same measure. They equal the same degree. So in this case, it's 60 degrees that both of the angles equal. And when we have an angle bisector cuts the angle in half. So whatever the original angle is, it is now half of it. So the original angle was 120 degrees in this case. It is now 60 degrees each of those because of the angle bisector. We also have adjacent angles. Adjacent angles are two angles that are next to each other. And then we have a linear pair. A linear pair are two angles that are adjacent to each other that create a line. Vertical angles are angles that are opposite each other. So 1 and 3 and 4 and 2 are vertical angles. So we're going to use all these ideas to help us identify angles. So with some of these, it's just going to be identifying, than others, we're going to have some work that we're going to show. So let's go ahead and start off with example 1. So we want to name all the angles that have D as its vertex. So D is right here. So we want to name all angles that have that as our vertex. So we have a bunch of different angles. So one of the angles that we have would be EDF, EDF. Notice that D, our vertex, is always going to be in the middle of all these. And then we have angle EDG. Then we would have angle FDC, angle FDC. We'd also have angle GDC, angle GDC. We'd also have angle GDH, angle GDH. Again, the vertex is always going to be your middle one. Angle CDH. And then lastly, angle FDH. And then you can pause the video and you can trace each of these angles on here and find out where they are. So EDG, so that would be this angle right here. GDH, that'd be this angle right here. Name two of the sides of angle 2. So angle 2 would be right here. So what would be the sides of angle 2? Well, that would be ray BA, and that would also be ray BG. So ray BA and ray BG. Name a point that's interior to angle FDE. So we have angle FDE. So that's right here. So a point that would be interior there would be point A. That's inside of this. So point A. And then name a point or points in the exterior of FDE. DE. So outside of this one right here, that could be points C, because C is outside of here, H is outside of there, and G is outside of there. So C, H, G, all three of those are outside of this. All right, let's take a look at an example with congruent angles. So in the figure, ray BA and ray BC are opposite rays, and BD bisects them. So we have ray BD bisects angle ABE. So it's bisecting this, it's not bisecting the straight angle. So if the measure of angle ABD, so ABD is 4x plus 14, and then DBE is 8x minus 32. We want to find DBE. Well, it doesn't matter which one we find because we know this bisects it. So since it bisects it, that means that 8x minus 32 equals 4x plus 14, because we know angle DBE is going to be congruent to angle ABD. And since they're congruent, they will be equal to each other, and then we can solve this. So which is smaller, 8 or 4? 4 is smaller, so I'm going to subtract 4x from both sides. That gives me 4x minus 32 equals 14. Add 32 to both sides. Gives me 4x equals 46. And then I'm going to divide both sides by 4, and I'm going to get 11.5. So x equals 11.5. So that's how much x is, but we want to plug it in and find what it's going to be. So measure of angle DBE, which is 8x minus 32. So it's going to give me 8 times 11.5 minus 32. Well, 8 times 11.5 is 92 minus 32. So this would be 60 degrees. So the measure of that angle is 60, and the measure of that angle is also going to be 60 degrees. Let's take a look at example 3. So example 3 is identifying some more different types of angles. So we have this lamp, and it's made of 2 intersecting metal bars. So how many pairs of adjacent angles do we see in this figure? So we see how many different pairs? So we've got one angle here, so that's 2 pairs, one angle here, another pair, one angle here, that's another pair, one angle here, another pair. So we have 4 pairs, but we only have to list 2. So let's list 2. So we're going to say angle DBC, so angle DBC, and angle DBC, and then angle CBE. Angle CBE. So that's one pair. Another pair would be angle EBA and EBA. So adjacent to that would be ABD. Angle ABD. So this little symbol that I keep doing, just in case you're wondering, is angle. It's just a short way of saying angle. Name 2 pairs of vertical angles in the figure. So our vertical angle would be this one and this one because they're opposite each other. This one and this one because those are opposite each other. So we would have angle DBA, angle DBA, and angle CBE, CBE. So that's this angle right here, this angle right here. Then our other angle would be angle ABE and this angle right here, and then it's going to be this angle down here, angle DBC. How many linear pairs do you see in the figure? List each linear pair. So when we look at this, we have 4 linear pairs in the figure. So let's list them out. So it's basically kind of coming up with our adjacent, because when you put the two adjacents together, this and this, you get a linear pair. This and this, you get a linear pair. So our linear pairs are going to be DBA, angle DBA, and angle ABE, ABE, angle ABE, and angle EBC, angle EBC. Then we also have angle EBD, or EBC, and CBD, angle CBD. And then lastly, we have angle CBD and angle DBA. Now we want to find the measure of angle EBC. So EBC. Well, we know that that is a vertical angle to ABD. So angle EBC. Let me make that a little better. EBC. EBC is vertical to angle ABD. Angle ABD. So the measure of angle EBC, since they are congruent, that means that EBC is going to also equal 138 degrees, because congruent means that they are the same, so they are equal to each other. And then we want to find the measure of angle ABE. So ABE. Well, if these two make a straight angle, which has a measure of 180 degrees, we would do 180 degrees minus 138 degrees, which would give us 42. So the measure of angle ABE equals 42 degrees. So notice how in A, B, and C, we are just listing off our pairs based on the notes that we took. Then D and E, we did need to show some work. So our work here in D is just that there are vertical angles. And our work here in E is that it's 180 minus 138 to give you 42 degrees. So go ahead and write a summary of what we learned today with angles and congruence. What makes up an angle? How can congruence help us out? And then use these notes to help you answer the practice questions today.